Great Scott! Grab your flux capacitors, because we're hitting 88 miles per hour to unravel the science behind Back to the Future. This 1985 masterpiece didn't just gift us Marty McFly's iconic hoverboard skills, it also threw a banana peel at physics and said, "Let's see if you slip." From DeLoreans doubling as time machines to Doc Brown's hair-defying gravity, we're diving into what the film nailed, what it hilariously ignored, and how it stacks up against actual science. So hold on to your plutonium, because where we're going, we might need roads after all. The DeLorean, a time machine with style. In Back to the Future, Dr. Emmett Brown transforms a DeLorean DC-12 into a time machine, requiring 1.21 gigawatts of power and a speed of 88 miles per hour to activate the flux capacitor. Why a DeLorean? Its gull-wing doors and stainless steel body made it look futuristic, the perfect vessel for traveling through time. In reality, the DeLorean wasn't exactly a speed demon, maxing out at about 130 miles per hour on a good day. Bob Gale, the film's screenwriter, chose the DeLorean because it's both flashy and impractical, adding a quirky charm to the story. The 88 miles per hour speed, however, has no scientific significance. It was simply chosen because it sounds cool and works dramatically. As for the 1.21 gigawatts, the film humorously overstates the energy requirements for time travel. A gigawatt is a billion watts, the amount of energy a small city uses in a day. To put this in perspective, today's fastest supercomputers only consume a few megawatts. The number 1.21 was another creative choice to make Doc Brown's exclamation sound dramatic. However, modern physicists believe any time travel device would require enormous amounts of energy, potentially even rivaling that of an exploding star. While the DeLorean won't be taking us to 1955 anytime soon, its cultural impact is undeniable. DeLorean sales skyrocketed after the movie, turning it into an icon of 80s pop culture. Time travel mechanics, theories, and paradoxes. The film introduces audiences to the concept of time travel, sparking curiosity about its feasibility. According to Einstein's theory of special relativity, time dilation occurs as objects approach the speed of light. Imagine an astronaut traveling at near-light speeds. Time for them would pass much slower than for someone on Earth. This phenomenon, called time dilation, has been experimentally verified using atomic clocks on airplanes and satellites, proving that time is not absolute but relative. However, traveling to the past is an entirely different beast. Theoretical physicists have hypothesized mechanisms like closed time-like curves and wormholes to explain backward time travel. Wormholes, often called Einstein-Rosen bridges, are theoretical shortcuts through space-time. While exciting in concept, creating or stabilizing a wormhole would require exotic matter with negative energy, something that hasn't been observed in the universe. Back to the Future also delves into the grandfather paradox. If you travel back and prevent your parents from meeting, do you cease to exist? The film dramatizes this, with Marty McFly jeopardizing his existence by interfering with his parents' first meeting. While modern science doesn't yet allow us to test such paradoxes, some physicists propose that any actions taken in the past would always lead to the present as it exists, aligning with the Novikov self-consistency principle. Essentially, you can't change history because everything you do was always part of history. Alternate timelines, a multiverse of possibilities. One of the most fascinating aspects of Back to the Future is its exploration of alternate timelines, especially when Biff Tannen uses the almanac to alter the past for personal gain. This leads to a dystopian alternate 1985, where Biff is rich and powerful. This idea of branching timelines aligns with the many worlds interpretation of quantum mechanics. According to this theory, every decision spawns a new universe, where all possible outcomes occur simultaneously. If you flip a coin, in one universe it lands heads, and in another it lands tails. Theoretically, time travel could allow you to jump between these timelines. While this idea makes for incredible storytelling, It's also rooted in theoretical science. Researchers at institutions like MIT and Caltech have explored the mathematics of parallel universes, though evidence for their existence remains elusive. Some theorists argue that alternate timelines could explain certain anomalies in quantum experiments, such as particles behaving as if they exist in multiple states at once. In Back to the Future, these alternate realities create high stakes for Marty, forcing him to fix the timeline before it's too late. The flux capacitor. Fiction meets physics. The flux capacitor is the fictional device that makes time travel possible in the Back to the Future universe. Doc Brown describes it as the result of a head injury and a sudden vision of how to manipulate time. While there's no real-world counterpart to the flux capacitor, the concept touches on intriguing physics ideas. For instance, some physicists have speculated about using immense gravitational fields or black holes to bend spacetime, creating a loop that could theoretically allow for time travel. Wormholes are another concept that mirrors the flux capacitor's functionality. Kip Thorne, a Nobel Prize-winning physicist, has written extensively about the theoretical physics of time travel. He suggests that traversable wormholes could act as a bridge between 2 points in spacetime. However, the amount of energy required to stabilize such a wormhole is beyond anything humanity could produce. The flux capacitor might be pure fiction, but its ability to spark scientific curiosity is its greatest legacy. Temporal paradoxes and self-consistency. Temporal paradoxes are where Back to the Future really cranks up the Great Scott factor. The whole plot hinges on Marty McFly accidentally preventing his parents from meeting, thus risking erasing his own existence. Classic case of the grandfather paradox, right? It's the ultimate brain-bending what if you went back in time and stopped the event that led to your birth. How could you exist to stop it in the first place? It's enough to make Doc Brown's hair stand up even higher. While the movie milks this for dramatic effect, physicists haven't let the question slide. Enter the Novikov self-consistency principle, the science nerd's way of saying, calm down, the timeline's got this. This theory suggests that time travel could be possible, but here's the twist. Anything you do in the past was always part of history. So if Marty had gone back to warn his parents, his warning would have been part of what got them together in the first place. It's like history is playing 4D chess with itself, completely unalterable and perfectly consistent. This clever loophole keeps timelines from imploding under the weight of paradoxes. Of course, it's all theoretical because, sadly, we're not quite ready for time-hopping DeLoreans yet. Time travel, fact or fiction? Time travel. Is it fact, fiction, or just an excuse for Doc Brown to yell "Great Scott" every 5 minutes? As of January 2025, it's still firmly planted in the realm of theory, but that hasn't stopped scientists or Hollywood from dreaming big. Einstein's theories of relativity suggest time travel could be possible under the right conditions, like zooming close to the speed of light or jumping through a wormhole. Sounds easy, right? Well, hold your hoverboard. Our current tech is nowhere near pulling off such feats. The closest we've come. European Council for Nuclear Research Large Hadron Collider, where particles zip around at near-light speeds, creating measurable time dilation. Cool, but not exactly a DeLorean with style. Back to the Future, of course, skips the messy science and goes straight to the fun, but it does succeed in sparking curiosity about time travel. And that's no small feat. Today's researchers are still chasing these ideas, with quantum computing and astrophysics helping us inch closer to unlocking time's mysteries. While we're not zipping through centuries just yet, Einstein's work has already revolutionized how we live. Your GPS wouldn't even work without accounting for time dilation. So while we may not have flux capacitors, understanding time has given us some pretty groundbreaking tech and the hope that maybe, just maybe, one day we will crack the code. Wasn't that a time-traveling whirlwind? If you enjoyed this video, make sure to hit that like button. It's your plutonium to fuel us. Don't forget to subscribe and turn on notifications, because where we're going, you'll want to come along for the ride.